Bismillahirrahmanirrahim. Assalamu alaikum. Our today's topic is about buffer solution. Now let's dive in our topic. Buffer solution is a water solvent based solution which consists of a mixture containing a weak acid and the conjugate base of the weak acid, or a weak base and the conjugate acid of the weak base. They resist a change in pH upon dilution or upon the addition of small amounts of acid or alkali to them. The pH of buffer solutions shows minimal change upon the addition of a very small quantity of a strong acid or a strong base. They are therefore used to keep the pH at a constant value. What is buffer solution? The buffer solution is a solution able to maintain its hydrogen ion concentration, that is pH, with only minor changes on the dilution or addition of a small amount of either acid or base. Buffer solutions are used in fermentation, food preservatives, drug delivery, electroplating, printing, the activity of enzymes, blood oxygen carrying capacity need a specific hydrogen ion concentration, that is a specific pH. Solutions of a weak acid and its conjugate base, or a weak base and its conjugate acid, are able to maintain pH and are buffer solutions. Types of buffer solutions. The two primary types into which buffer solutions are broadly classified into are acidic and alkaline buffers. Acidic buffers. As the name suggests, these solutions are used to maintain acidic environments. Acid buffer has acidic pH and it is prepared by mixing a weak acid and its salt with a strong base. An aqueous solution of an equal concentration of acetic acid, which is weak acid, and sodium acetate, which is a salt of acetic acid with a strong base. Sodium acetate is formed by the neutralization reaction of acetic acid with sodium hydroxide. So, sodium acetate is a salt of weak acid with a strong base. Sodium acidic buffers has a pH of 4.74 to 4.75. pH of acidic buffer solutions is below 7. These solutions consist of a weak acid and a salt of a weak acid. An example of acidic buffer solution is a mixture of sodium acetate and acetic acid, and its pH value is approximately 4.75. Now, alkaline buffers. These buffer solutions are used to maintain basic conditions. Basic buffer has a basic pH and is prepared by mixing a weak base and its salt with a strong acid. The aqueous solution of an equal concentration of ammonium hydroxide and ammonium chloride has a pH of 9.25. The pH of basic buffer solutions is above 7. They contain a weak base and a salt of the weak base. An example of an alkaline buffer solution is a mixture of ammonium hydroxide and ammonium chloride, and its pH value is equal to 9.25. The mechanism of buffering action. In solution, the salt is completely ionized and the weak acid is partly ionized. It is the sodium acetate, which is a salt of weak acid and strong base. In aqueous solution, it is completely ionized into sodium ion and acetate ion, while weak acid are those acids which is partly ionized or which provide a small amount of H positive ions in aqueous solution. Largely, it is present in undissociated form, that is, acetic acid in aqueous solution provide a small number of ions. In this example, it can be noted that the sodium acetate almost completely undergoes ionization, whereas the acetic acid is only weakly ionized. The equilibrium reactions can be written as it is acetic acid which is present in undissociated form in large extent and is provide a small number of H positive and acetate ion because it is a weak acid. So it is partly ionized. While the sodium acetate is completely ionized into Na positive and acetate ion. If sodium acetate is added to acetic acid solution, it does not react directly with acetic acid or with water. However, the increase of acetate ions from sodium acetate suppresses the ionization of acetic acid. The following reactions sum up to show a common ion, that is acetate ion. It is acetic acid. When it dissolves in water, it provides a small number of acetate ion, and H positive is react with water to form hydronium ion, that is H3O positive. While acetate, sodium acetate ionized to form acetate ion and sodium ion. So, the common ion in this reaction is the acetate ion, that is CH3COO negative, which is a common ion and provided by both the reactants, that is acetic acid and sodium acetate. When strong acids are added, the H positive ions combine with the acetate ions to give a weakly ionized acetic acid, resulting in a negligible change in the pH of the environment. If H positive is added to a solution, it combines with acetate ion to form acetic acid. It maintains the pH of the solution. When strongly alkaline substances are introduced to this buffer solution, the hydroxide ions react with the acids which are free in the solution to yield water molecules, as shown in the reaction given below. Hydroxide ion react with acid, that is H positive of acid, to form water molecule. Therefore, the hydroxide ions react with the acid to form water and the pH remains the same. It is the buffer action. It is pure water and its pH is 7. After adding acid, a change in pH occurs and pH becomes 3.2. While in buffer solution, after adding a same amount of acid, there is a negligible change in pH, that is 6.8, which is nearer to 7. It is water, pure water, its pH value is 7. After adding base, the pH of the solution is changed from 7 to 11.5, and the solution turns basic. While in buffer solution, its pH is 7. After adding the same concentration of base or the same amount of base, there is a negligible change in pH, that is 7.2, which is nearer to 7. This solution has stable pH because of buffer action. Now, the uses of buffer solutions. There exist a few alternate names that are used to refer buffer solutions, such as pH buffers or hydrogen ion buffers. An example of the use of buffers in pH regulation is the use of bicarbonate and carbonic acid buffer system in order to regulate the pH of animal blood. Buffer solutions are also used to maintain an optimum pH for enzyme activity in many organisms. The absence of these buffers may lead to the slowing of the enzyme action, loss in enzyme properties, or even denature of the enzymes. This denaturation process can even permanently deactivate the catalytic action of the enzymes. Now, the quote of the day: a bird sitting on a tree is never afraid of the branch breaking because her trust is not on the branch but on its wings. Always believe in yourself. Thank you very much. Allah Hafiz.